Do you know the one secret that could save humanity? Like if you knew it, you could be rich beyond your wildest dreams, because it could change everything. Well, there is an answer. And this isn't some joke or meme or anything. It's a real secret that can fundamentally change the world. It's been hidden away for years. But now, finally, it's becoming more apparent. As it turns out, we are on the verge of making something huge happen. For we have discovered a $100 trillion energy secret. Yeah, seriously. So let's talk about what it is and how it's going to save us all. But before we get into it, alright, so you may not realize it, but right now, almost every single nation on Earth is fighting to own this secret because they know what it could mean. The most powerful nations want to be the first to use it. Most governments have devoted hundreds of millions of dollars to finding it, and big companies are willing to spend billions to find it. They call it the Holy Grail of science, and they say that it could literally save mankind. So what is this incredibly powerful secret that will determine the future of civilization? Well, it's actually quite simple. This is the secret power of the stars. Basically, we've figured out how to bring the power of the sun onto Earth. Like, think about it. The sun is this massive nuclear fusion reactor that provides limitless clean energy. If we can just figure out how to replicate that process here on Earth, then we would basically be set for the next billion years. Seriously, the possibilities are endless. Yeah, and I know you probably already know about solar panels and wind turbines and stuff. But that's just a tiny fraction of what's possible. Like the amount of energy the sun dumps onto Earth every second is enough to power the entire planet for millions of years. Solar panels only capture a tiny bit of this energy and convert it into electricity, whereas nuclear fusion could allow us to harness the full power of the sun directly. And the best part is that this process is known as nuclear fusion, and it's not the same thing as nuclear fission that powers most of our current nuclear reactors. No, in fusion, we actually combine light atoms like hydrogen to form heavier ones, like helium, and in doing so, they release massive amounts of energy. This is the exact process that powers the sun and other stars. Like, imagine taking two small balls and smashing them together to make a bigger ball. When you do that, you might need a little bit of extra energy to push them together. But once they're together, the bigger ball has more energy than the two smaller balls had. And that's exactly what happens in nuclear fusion. We put a tiny bit of energy into it, and then we get a lot more energy back out. Now, you might be wondering where we're going to get the fuel for this process. And that's another great thing. It's literally everywhere. Like here on Earth, we have plenty of hydrogen available. It's actually in seawater. There's this stuff called deuterium, which is an isotope of hydrogen with an extra neutron. And then there's tritium, which is another isotope of hydrogen with two extra neutrons. These isotopes are what we would use as fuel for our fusion reactors. So not only is the process itself extremely efficient, but we also have a seemingly limitless supply of fuel. It's pretty much everywhere. Now, you may be thinking, great, we found the secret, but how do we actually use it? Well, that's where things get a little complicated. While it's great that we've discovered how to combine these atoms to release energy, the real trick is being able to control the process. To fuse these atoms together, we need to heat them up to millions of degrees Celsius. Like literally millions. At those temperatures, the atoms move so fast that their electrons fly off, creating a hot plasma. And if we can't contain that plasma, it'll just burn up everything around it. And so, the real challenge is figuring out how to hold that superheated plasma in place long enough for the atoms to fuse together. There are two main ways to do this. First is through magnetic confinement. This is the approach taken by most major fusion projects. They use giant magnets to keep the plasma away from the walls of the reactor. Another way is through inertial confinement, which uses lasers to heat and compress the plasma. Either way, the result is the same, a super hot ball of plasma where the atoms can fuse together. But that still doesn't solve the main problem, which is that it takes a lot of energy to start the process in the first place. This is the biggest hurdle that we need to overcome. You see, The whole point of nuclear fusion is that it's supposed to be more efficient than other forms of energy production. It needs to produce more energy than it consumes, but we're still struggling to reach that point. Every experiment so far has taken more energy to start the reaction than they've gotten out of it. This is why nuclear fusion has been called the more energy in than out problem. This is the challenge that we face today, and until we overcome it, nuclear fusion will never be a viable energy source. It doesn't matter how efficiently it produces energy or how cleanly it produces energy. If we can't get it to produce more energy than we put in, then it's useless. And that's why this has been such a hard nut to crack. Now, despite all these challenges, it hasn't stopped us from trying. And over the years, we've made some amazing discoveries that have brought us closer than ever to solving this problem. In fact, researchers at the Joint European Torus or JET recently achieved a new milestone. They were able to produce a fusion reaction that generated more energy than the amount of energy used to start the reaction. It was only a small amount, like less than 10%, but it's still a huge deal. Like never before have we produced more energy out than we put in, and so this gives us hope that it's possible. We just need to keep pushing forward. But even with all the progress that we've made, nuclear fusion is still a long way off from becoming a practical energy source. In fact, many experts predict that it will be at least a few decades before we have commercial fusion power plants. And even then, it may not be as cheap or as easy to use as other forms of energy. Still, the potential benefits are too great to ignore. Like just imagine a world where we have unlimited access to clean, safe, sustainable energy. It could end the energy crisis. It could end pollution. It could end energy geopolitics. It could change everything. And that's why so many countries are investing so much money into it. They see the potential benefits, and they want to be the ones to reap them. But even if it does take a few decades to make nuclear fusion a reality, it will be worth it. It's the secret that could save humanity and change our destiny. So keep pushing forward. Keep innovating. Keep dreaming big. Who knows? Maybe one day soon we'll all live in a world powered by the stars. Do you think everyone should have access to this kind of technology? Let us know in the comments below. And like this video if you like science and technology. Subscribe this channel.